A common virus can trigger multiple sclerosis, according to a huge new study. This is by Nicoletta Lanson, Life Science on Science Alert. Multiple sclerosis, an autoimmune disease that affects the brain and spinal cord, may emerge after infection with Epstein-Barr virus, EBV. An estimated 90-95% of people catch EBV, also called human herpes virus 4, by the time they reach adulthood, according to the clinical source Up to Date. In children, the virus typically causes an asymptomatic or very mild infection, but in teens and young adults, EBV can cause infectious mononucleosis, better known as mono. Despite EBV being a commonly caught virus, there is evidence to suggest that infections with the virus are a risk factor for multiple sclerosis, a far less common condition. Studies have shown, for example, that people with multiple sclerosis have remarkably high levels of EBV-specified antibodies, immune molecules that latch onto the virus, compared with those without the disease. And prior research hinted that catching mono raises the risk of developing multiple sclerosis later in life. Given that most people catch EBV at some point, however, it's been difficult to demonstrate that these infections may actually be an underlying cause of multiple sclerosis. Now, a new study published Thursday, January 13, in the journal Science, provides evidence for this idea. By combing through data from about 10 million U.S. military members collected over the course of 2 decades, the research team found that the risk of developing multiple sclerosis increases 32-fold following an infection by EBV. They found no such link between the autoimmune disease and other viral infections, and no other risk factors show such a high increase in risk. The study shows that EBV is clearly associated with the development of multiple sclerosis, while other viruses are not, said Dr. Lauren Steinman, a professor of neurology and neurological sciences at Stanford University School of Medicine, who was not involved in the study. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Compelling evidence. We've been working on this hypothesis that EBV may be a causal risk factor for MS for about 20 years, said Cassandra Munger, a co-senior author of the study and a senior research scientist in the Neuroepidemiology Research Group at the Harvard T.H. Chan School of Public Health. To test this hypothesis, the team set out to identify individuals who had never been exposed to the virus, track their EBV status through time, and see if their chance of developing multiple sclerosis increased following exposure. Again, this is a challenging hypothesis to test because over 95% of the population is infected with EBV by adulthood, Munger said. So to identify people with no prior EBV exposure, the team combed through a unique dataset curated by the U.S. Department of Defense. The Department of Defense maintains a repository of serum, the yellowish fluid portion of blood, sampled from military personnel. At the start of their service and about every 2 years afterwards, active duty military members provide serum for HIV screening, and any residual serum for the test gets placed in the repository. Serum contains antibodies, and thus these stored samples provide the researchers with a way to check each person's EBV status through time by checking for antibodies against the virus. The team then used this data to investigate the potential link between EBV status and the onset of multiple sclerosis. Of course, their data only focused on these individuals who became exposed in their early 20s rather than during childhood. Using medical records, they identified 801 individuals who developed multiple sclerosis during the study period and who had provided at least 3 serum samples prior to their diagnosis. They found that 35 of these 801 individuals had tested negative for EBV-specific antibodies at their initial serum sampling, but in time, all but 1 person became exposed to the virus. So 800 out of the 801 caught EBV before developing multiple sclerosis. The team ran several tests to see if any other viruses shared such a strong correlation with the disease, but found EBV was the only one to stand out in this way. And the team spotted another hint that EBV triggers multiple sclerosis. In the serum of those who developed the disease, the team spotted signs of nerve damage that showed up after their EBV exposure, but before their official MS diagnosis. In multiple sclerosis, the immune system mistakenly attacks myelin, an insulating sheath that surrounds many nerve fibers, and this damage impairs the ability of nerve cells to transmit signals. Early signs of this nerve cell damage can appear up to 6 years prior to the onset of multiple sclerosis, according to a 2019 report in the journal JAMA. So the team looked for hints of this damage in the serum samples. Specifically, they looked for a protein called neurofilament light chain. Those concentrations go up in the blood following damage to nerve cells. This protein increased in the serum of those who went on to develop multiple sclerosis, but only after they became exposed to EBV. For those in the control group who never developed multiple sclerosis, the concentration of neurofilament light chain in their blood remained the same before and after they caught EBV. This aligns with the idea that EBV exposure does not jumpstart multiple sclerosis in everyone, but rather only in susceptible people. Munger said, the infection seems to occur prior to any evidence of neuron system involvement. Taken with other study results, this is really, we think, compelling evidence of causality. It kind of inextricably links EBV infection and the development of MS, Robinson said, echoing the statement. That said, the work cannot reveal exactly why this link exists, but a recent study led by Robinson and Steinman provides some clues. That study, posted January 11 to the preprint database Research Square, has not yet been peer-reviewed or published in a scientific journal. It suggests that in people with multiple sclerosis, specific antibody-producing cells appear in great numbers in the fluid surrounding the brain and spinal cord. These cells make antibodies that latch onto an EBV protein called EBNA1, but unfortunately the same antibodies also go after a similar-looking molecule on the cells that make the myelin. Several other studies also provide evidence of EBV-specific antibodies targeting components of nerve cells and the myelin sheath itself. Robinson said, I think that would be the leading hypothesis, that a viral component looks like a self-protein, and that is striking similarity drives the immune system to attack myelin. Of course, even with this mounting evidence, one big question remains. If most people catch EBV at some point, why do only some people go on to develop multiple sclerosis? The answer lies, at least in part, in their genes. Evidence suggests that specific versions of genes that regulate the immune system may make a person susceptible to multiple sclerosis, Robertson said. Within that genetic context, EBV can then light on the fuse that sets off the development of multiple sclerosis. But perhaps in the future, an EBV vaccine could prevent that fuse from ever being lit, or therapeutics could counter the virus's lingering effect on the immune system, thus stopping multiple sclerosis in its tracks, he said. Now that in the initial trigger for MS has been identified, perhaps MS could be eradicated, Steinman and Robinson wrote in their commentary. I hope so. This is on Science Alert. Please leave your comments. Thank you for your support.